All right, hello. It's that time again. I am making a practice exam and solving it for you. So this exam gonna cover section 10.2 all the way to 10.5, 4.1, 4.2, and 4.4. Number one, match the graph to one of the following function. I have 2 to the x, 2 to the x plus 1, and 3 to the x. So these are exponential growth, right? Because the base is bigger than 1, right? Now, all the exponential growth function go through the point 0, 1, right? No matter how big is the base is, 2, 3, 5, 100 to the x, it still goes through 1. The only difference is that the bigger base, it's gonna make the function grow faster, right? So if you compare 2 to the x and 3 to the x, see which function go faster. The faster one would one have the bigger base, which is 3 to the x, right? So I see the function that go through 0, 1 here out of the three pictures is the first one and the third, first and the second, right? It looks like the first one grows slower than the second one. So here go through 0, 1. 0, 1. They both go through 0, 0, 1, but the second one grow faster. So it must be 3 to the x. Right? So the first one should be 2 to the x. Maybe I'll just say a here. For the third one it is 2 to the x plus 1. So that means you move to the left 1 unit, right? So this right here imply you move left. Maybe I'll do like this. Left, no, not left, not right. Left 1 unit. So from 0, 1, it used to be here. You move to the left 1 unit, so it's gonna be here, which just makes sense, right? So this one should be B, which they all make sense, right? Or you can use elimination. Solve each exponential equation. So this is the easy K between the two. Remember exponential equation, there are two types. The easy one is that the one that you can change the right-hand side into the same base, and then you set the power equal. Excuse me. And the other one that you cannot change the right-hand side into the same base, then that one you have to use log. Okay, so this one I have 2 to the x, 3x minus 8 on the left. On the right-hand side, I'm gonna change 16 into 2 to some power. So 2 to the 4 is the same thing as 16. Right. Now, the behind the scenes here is the reason you set 3x, the reason you cancel the 2 here, and set 3x minus 8 equal 4, is that because you take log both sides? Right, log base 2 both sides. It's kind of like taking square root both sides. Does it make sense? Log base 2 and then the 2 cancel because they inverse of one another. So that's why the powers drop, and they let them you let them equal to each other. On the exam, I'm not gonna ask you to show me every single step, but decent number of steps, right? A lot of time people just kind of automatically drop it and then set the power equal. So at 8, I have 3x equal 12. Divide both sides by 3x equal 4. And you can check. You can check if you want. It is not required, but you can check. Put an x into the original. So 3 times x is 12. 12 minus 8 is 4. 2 to the 4 is 16. Right, so it's check. B, let me draw a little line here. B, I have 2 to the x squared divided by 2 squared equal to e to the x. I'm sorry, did I say 2? E to the x squared divided by e squared. So that on the left-hand side, if you remember this rule a while ago, I think it's the very first exam. If I have a to the n divided by a to the n, notice that they same base, then quotient becomes subtraction, right? So it's going to be a to the m minus n, right? So same thing here. I got e and e here, so they both same base. So what I can do is I'm gonna take e to the x squared minus 2 to just subtract the powers equal e to the x. And again, if you fancy, you can say I'm taking ln both sides. You don't have to. At this point, you are automatically dropping the e if you want, just dropping it because they all same, right? If the base is same, in order for them to be in the equation, the top has to be the same. Just logic, right? So x squared minus 2 equal x. Move everything to the left and then factor x squared minus x minus 2. Notice that I put it in descending order. And now I can factor x and x, 2 and 1, minus plus. So that means x equal -1 or x equal 2. And then you can check it yourself. Okay. Number 3, Nazerhi, I apologize if I didn't say the person name correctly. Deposit 8,000 in a certificate of the deposit. The annual interest rate is 6%. If I was you, I'll do this right away. 6% is 0.06, so I don't forget. The interest will be compounded quarterly. What does it mean to be compounded quarterly? That means n is 4. Quarter, 4, right? So this is the compound interest problem. And of course, naturally, I'm going to give you the formula. You don't have to memorize it. I'm going to give you 2 formula actually on the exam. A equal P, I guess I try to remember. P times quantity of 1 plus R over N to the NT, or A equal PERT, P times E to the RT. Right? It's your job to pick which one you want to use. So compound quarterly, so that means I'm going to pick the first one, right? Compound n times. How much will the certificate be worth in 10 years? So A equal, I'm going to use the first one, A equal P times 1 plus R over N to the NT. Move up a little bit. Principal is initially that person put in $8,000 deposit. Rate is 0.06. N is 4. And 4 times T is 4 times 10. You want to know how much that person make in 10 years. So let me show you how you put in a calculator. Let me clear that. So what is that? It's 8,000. Parenthesis 1 plus, and then second frac. Now, if you second frac will give you a fraction. So R is 0.06, N is 4 to the N times T, N times T, so 4, oops, my bad, hang on. Raise, I gotta raise to the power. N is 4 times T is 10, or you just say 40. Oh, I'm sorry, it shouldn't be that much. It's a 0.06, not 0.6. Let me enter. Second insert right there. All right, that's making more sense. That person make, so from 8,000 that they make $14,512, $512.15, right? Make more sense than the other one. If I be making that much, I'm not be teaching you now. Okay, so 4,512.15 cents. Round it to the nearest cents, okay? By the way, you notice that if the next number is 5 or greater, I round up a unit. But reality in the bank, they don't. They're just gonna say $14,512 and 14 cents. They don't round up, no matter how big the number next to it. It's how to make money. Yeah, box that. Find the value of x in each, sorry, it should be a space between x and n, each logarithmic equation. Okay, so the first one, I have log base 2 of x equal 8. It's a good habit to put a parenthesis around your input, even though the input is only one number or one letter. So what we're gonna do next is we're gonna change this into exponential form, right? Remember the little tornado arrow? So I have 2 to the 8, can't write the 8 correctly, equal x. Put in your calculator, x equal, let's see what's x equal. 2 to the 8. 256. Second, same thing, right? Second one, same thing. You put a little tornado thing. So 1/3 to the x equal 27. Notice that this is the exponential equation now, right? I need to change it into the same base. It's easier to work both sides for this problem because on the left-hand side, you have fraction. I don't like fraction base. If I was you, I would change it into a integer base. So let me remind you a rule. If I have 1/a to the 1/a to the x is equal to a to the negative x. Remember that? If you flip, you change the size of the power, right? In this case, you start out with positive, then it becomes negative. So this one is gonna be what? 3 to the negative x equal, on the right-hand side, it's gonna be 3q. Right? 3q is 27. Let me move up a little bit. I'm running out of space. Like that. Okay. So now I can drop, or you take log base 3 both sides, doesn't matter, just drop it. X, negative x equal 3, or better yet, x equal negative 3. Yes, the second one a little bit more involved. What C? 3 to the negative 3 equal x. So x equal 3 to the negative 3. Remember that rule I told you up here. Now you reverse engineer, right? You go from right to left. So you start out 3 to the negative 3, so it's going to be 1/3 to the third, right? So this is 1/3 to the third equal x. Well, 1q is 1, but 3q is 27, so x equal 27, 1/27. D, same thing. X squared equal 5 squared. Take square root both sides. Plus, oh no, you don't, I'm gonna put plus and minus over here. So x equal plus minus 5, right? Because 5 squared is 25. Now, is, we don't have log of a negative base, so we're gonna say we're gonna pick x equal 5. X equal 5. Yep, that's right. E is 10 to the log base 10 of 2. Again, one of the rule here, remember the inverse rule, the second rule, well, the second rule, yeah, second of the inverse rule, 10.4, I believe, 10.5, 10.4, 10.4. So, cancel. That's in that cancel, just 2. equal x. What about this one? What about this one? Same thing, right? You can cancel this. So square root of 2 equal x. On the exam, I want you to show me how you say for these problem E and F, it's kind of short. A lot of time people just give me the answer, which is fine, but show me how you give me the answer. In this case, I kind of see cancel, show you that because I cancel those two, therefore the two drop down. I want you to do the same thing, okay? Show me how you got there. All right, this one, 16 to the 1/4 equal x. 16 to the 1/4 equal x. Now you can plug in your calculator at this point. What's 16 to the 1/4? Basically, it's the 4 roots of 16, right? If you like, you can change it into this is 4 root of 16, which is 2, right? Because 2 to the 4 is 16. And then this one, root 3 to the 2nd equal x. Oh, this one easy. So x equal 3. On the exam, don't mess up this one. Number 5, solve each logarithmic equation, give an exact answer as well as the approximation to 4 decimal places, and remember to check your answers. For log, you need to check your answer. Okay, so the first one, I'm gonna change it into exponential. So 3 to the 4 equal whatever input that is, 5x minus 4. So 3 to the 4 equal 5x minus 4. 3 to the 4 is 81. Equal 5x minus 4. Add 4, so 5x equal 85. Divide both side by 5. X equal 8 divided by 5 is 1. 30 divided by 5 is 17. I have a feeling we did this before in the lecture. Oh, you gotta check. So let's check. You plug in 17 for x, right? You can check your calculator. So let's do this. Logs by 3. So you know where to go. Go to math. And right there, logs base, right? This is base 3 of, what is that? 5x minus 4. So 5x is 16. So 5 times, I'm sorry, x is 17. 5 times 17 minus 4. Or you can store x is 17. First, you want to equal 4. So yes, it check. Check. This one, ln e of 5 to the x equal 30. Ln e is 1, so that's cancel. So just 5x equal 30. Divide both side by 5, x equals 6. And again, you can check it yourself. And it's checked. C, we have 3 logs. On the left hand side, you have 2 logs, 2 separate logs. The first thing we do is we need to combine the log on the left hand side first. Don't drop it. Don't do this. The line will just kind of drop it. They see it and it just automatically drop it and then let x plus x minus 5 equal 24, which is wrong, right? You're gonna combine the log first. You're only allowed to cancel if you have a single log on the left and a single log on the right. So if I combine the log on the left, that will be product rule, right? So it will be log base 6 of x times x minus 5 equal, rewrite this log base 6 of 24. Now you can cancel both sides, right? Cancel both sides. Cancel log both sides. So I have, and if I distribute this, I have x squared minus 5x equal 24. X squared minus 5x minus 24 equals 0. Factor. See, a and 3 minus plus So x equal -3 or x equal 8. And then you're gonna check. Let's see. Can't be -3, right? Because the first thing you plug in log base 6 of -3, that's negative input. We don't want that. So the first thing first, you can safely cross that out. What about 8? X equal 8. Let's check with the calculator. What I'm going to do is I'm going to store, so 8 and then STO to X. Oh, done. Here's something. X is now X is remember as 8. Okay, so now log base 6, math log base 6 of X plus log base 6 again. What is that? Yeah, was it 5x? Was it x minus 5 and then 24? X minus 5 and then equal that, right? And then just check the right hand side. The right hand side is log base 6 of 24. Same answer, right? So the left hand side equal the right hand side when x equal 8. So that means that is your solution. Okay, all right. D. Again, we need to combine everything before we cancel the log. And remember, the coefficient of a log has to be equal to 1 in order to cancel. So on the left-hand side, I'm going to use quotient rule, right? It's log base 2 of x minus 2 on the x plus 2 on the top first, and then 2x plus 9 on the bottom. And remember, this is the input. On the right-hand side, I'm gonna use the power rule. I'm gonna move that -1 to the power. So it's gonna be log base 2 of x to the -1. Now I can cancel that and that. So I have x plus 2 over 2x plus 9 equal x to the -1, or better yet, 1 over x. LCD here is x times 2x plus 9 over 1, right? And then you're going to distribute the LCD into the two sides, right? So on the left-hand side, the 2x plus 9 cancel. So I have x times x plus 2 equal the right-hand side, the x cancel. So it's just 2x plus 9. Distribute x squared plus 2x equal 2x plus 9. Now, if you subtract 2x both sides, this one cancel, right? So I have x squared equal 9. How do I solve for x? Square root. Don't forget plus and minus. So I have either x equal -3 or x equal 3. Can't be -3, right? On the right-hand side, you plug in -3, the log does not like that. So this one, not it. What about 3? Again, you can check with your calculator, like I did. I think it worked out. I think so 3 log 5, 6, 15. 5 over 15 is 1/3. Yes, it checked out. Number 6, this is what I meant by you have two types of exponential equation. The easy one is that you can change one of the number into the same base, right? Well, here you can't change 10 into 1/2 or even 2, right? So what we're going to do, we're going to use log. So what I'm going to do is, first thing first, maybe I'll take log base 10 because I need to bring the x down, right? It's all on the top. I need to bring it down. So I'm going to use log base 10 in this time. You can use log different base, okay? But I think it's best if you use log base 10. And I don't have to explain a whole lot, like whole another level. So log base 10, both sides. Log base 10 of 1/2 to the x equal log base 10 of 10. All right, so on the left-hand side, I can use a power rule and then bring the x down. So that means it will be what? X times log, instead of log by 10, I'm just gonna write log, okay? It's 1/2 equal. On the right-hand side, log 10 is, log by 10 of 10 is 1, right? I need to solve for x, so divide both side by log 1/2. Cancel. So x equal 1 over log of 1/2. Did I ask you to give decimal places? Maybe I should. Number 5, I think I messed up a little bit. I do ask for decimal's case. I just didn't put it there. So 1 over log 1/2. 1 divided by the log by 10, so log 0.5. 0.5 negative 3.3219. Negative 3.3219. Number 7. I'm sorry. Part B. I'm gonna use logs base 7 now. We logs base 7 now, so it's gonna be log base 7 of 7 e to the x minus 3 equal log base 7 of 35. Make sure you rewrite your thing correctly, okay? It's important. All right, so on the left hand side, log base 7 and 7 cancel. Yay. So now I have what? Oh, you know what? No. Ooh. It's 7 times e. Oh, goodness. Okay, there's nothing wrong with that. It's not wrong what I just did. It's just more step. Well, there's something wrong when I said the last part, but what I'm gonna do first, I'm gonna divide both side by 7. I think that's easier, right? Divide both side by 7. If you want to take log base 7, that's fine. It's not wrong, but you have to use the particle, the multiplication here. So divide both side by 7. Divide with you. On the left hand side, the 7 and the 7 cancel. You are allowed to cancel because there's multiplication, right? And here I have e to the x minus 3 equal 5. Guess what log base 1 I'm going to take? ln. ln. Yeah, whenever you see e, you should ln should pop up in here. Cancel. So I have x minus 3 equal ln 5, right? Don't forget to write the ln on the right hand side. Add 3, x equal ln 5 plus 3. And approximation here. Oh my god. Approximation like that. ln 5 plus 3, 4.6094. Number 7, I'll give you the formula, but again, you still have to do a lot of work. A bacteria double its original population in 24 hours. So that means the current population is twice the original population. How big will its population be in 72 hours? So that'll be 3 days, right? Okay, so first, so it's how big will it population be in 72 hours? Okay, so it's asking for what? Asking for A, right? How big it will become. So it's asking for the final population, final amount, which is A, big A, right? So in order to solve for big A, I need what? I need to get rid of A naught. We will. I need to know K. I have T, which is 72. They give us 72 hours, but I don't have K, which is a constant that I need to find, right? So the first piece of this problem is to find K. Find K. So the 5K, I'm going to use the first piece of information. A bacteria doubles its original population in 24 hours. So given, let me rewrite it here. A equal A naught e to the KT. You know, I'll give the formula on exam. So instead of A, I'm gonna replace A as 2A naught and rewrite everything out on the right hand side. Divide both sides by A naught, that's cancel, right? So I have 2 equal E to the K times T. I need to solve for, I'm sorry, I need to replace the T with 24 hours, right? 24 hours. So here's 24K. K times 24, same thing as 24 times K. Take ln both sides. We did this problem kind of similar to this. I think it's the same problem in the lecture. All right, ln E is cancel. So I got ln2 equal 24K. So K equal what? ln2 over 24. That's my K. Ooh. So now another part is to find the final amount. A equal A naught e to the KT. Well, we know what K is now. It's a all right, A naught. In 72 hours. A naught is something wrong with this problem. No, nothing wrong with this. They just don't give you the original population, like a specific number, but that's okay. We're just gonna treat the original population as A naught, right? So let's figure it out. How many times the current population is bigger than the original population? So let's go ahead and solve for this. So whatever you have, just throw in there. So A equal A naught, we don't know A naught. Well, sometimes they give it to you, the specific number, sometimes they don't, but that's okay. K is ln 2 over 24. And please do not cancel the 24 and the 2. They're not meant to be. And T in this times, it's gonna be 72 hours. All right, plug in the calculator for this part. For that part. Let's see. So E to the frac ln of 2 over what is that? 24 and time T to 72. 8. Wow, these are nice. So 8. That equal 8. So that mean is A equal A naught. So is 8 times as much, is 8 times as big as the original population. So this one say after 72 hours. Material multiply 8 times as large as the original population. That's what that means. A equal 8 A naught. All right, number 8, use the property of a logarithm to expand as much as possible. So this one, they want you to expand. I believe I didn't do this on the lecture. I should. But anyway, it's not bad, right? So this one is for you to practice all the law, all the properties of law, right? So expand. So first, I'm gonna use quotient. So you see that little division there. I'm gonna use quotient. You know what? Before I do that, let me do this. You see e to the -3? I need to get rid of that negative exponent. Well, in order to do that, you just flip them, right? Just flip the position of e. So instead of stay on the top, it's gonna stay in the bottom now. So it's gonna be equal ln of, let's see, on the top it's just x to the 5th. On the bottom is gonna be e to the 3rd, y to the 4, and then z to the 7. And now we're gonna use quotient. So ln of what? Ln of x to the 5th minus ln of e, let me put the parenthesis here, e cubed, y to the 4, z to the 7. Remember the rule? All right, ln of x to the 5th. I'm gonna move the 5 to the front. Power rule. You're gonna expand it until you cannot expand it anymore. Right, so it's gonna be 5 times ln of x, and that one is done. Now, the one in the parentheses, you're gonna do one step at a time. So first, I'm gonna use product rule. You say ln e cubed times y to the 4 times z to the 7. So product rule say what? Minus ln e cubed plus ln y to the 4 plus ln of z to the 7. Notice that I put the parenthesis around it. That's because the minus. You see y at the end. Rewrite 5 times ln. I don't feel like, I don't feel like rewriting the 5 times ln of x. So what I'm going to do is this. I'm going to simplify this one. So that one is what? I'm gonna, ln e is 1, right? So it's gonna be 3 plus what? Move the 4 to the front, 4 times ln of y plus 7 ln of z. Don't forget the minus, and now you can distribute the minus. That's why the minus is there. So equal 5 times ln of x minus 3 minus 4 ln of y minus 7 ln of z. Now, there's a shortcut to this. So this is everything. This is how you show your work. Now, if you're smart, there's a shortcut for this. Whenever you see whatever thing in the bottom is gonna take the minus. It's gonna take the minus. Right? So maybe you don't have to write this down. Here, I'll show you this. The alternative way, faster. So after I move the e to the cube to the bottom, now I know that I'm gonna use quotient rule and product rule at the same time. So ln x to the 5th is on the top, so it's gonna have the plus in front of it, which we don't write, right? Now e cubed, y to the 4, and z to the 7 in the bottom, so they all gonna have a minus. Minus ln of e cubed minus ln y to the 4 minus ln z to the 7. And all you have to do now is bring the 5 to the front, so ln 5 times ln of x minus, well, this one is still cancel, ln e still cancel. No worries. So it's going to be 3, this 3, right? Minus, bring the 4 to the front, 4 times ln of y minus 7 times ln of z. And then you're done. The same answer. They all the same answer. Okay. So the thing is that if your number, oh sorry, not number, but your factor is in the bottom, it take the negatives in front of this log. Okay. The one on the top have the positive signs in front of the log. Whichever way you want to do, that's fine by me. They all have the same answer. All right, number 9, solve system of equation using either addition or elimination. When I say addition, I meant substitution. Okay. Maybe I should say substitution. Substitution. All right, so for part A, I think it's easier for me just to use elimination. Why? Because the y or x is not solved for already, and if you want to solve for x or solve for y, you're gonna run into fraction, which I don't like, right? So best is elimination. Pick one variable, multiply something by its opposite, and then add it so it will be canceled, right? So I'm gonna pick y to cancel y. So I'm gonna multiply the first row or the first equation by -1. Rewrite this. I have 7x now minus 3y equal -5. Rewrite the second one, 27x plus 3y equals 7. And then you add, this should be canceled. So I have 34x equal what? 2. Divide both sides by 34x equal, let me do slowly, 2 over 34, which is 1 over what? 17, right? So x equals 17. You plug it back into one of the original. Pick one, doesn't matter to me. Pick one. It has to be original though, okay? So I'll pick the first one. -7 times 1 over 17 plus 3y equal 5. Let me do this. So -7 over 17 plus 3y equal 5. Add 7 over 17 both sides, so I have 3y equal 5 plus 7 over 17. Use calculator for this. You don't have to do by hand. So 5 plus 7 over 17. And then you go to math. You see frac, hit the enter button twice. 92 over 17. 3y equal 92 over 17. Multiply both sides by 1 over 3. Right? So y equal what? Let me do this just nicer. 1 over 3, 1 over 3. And again, you can use calculator if you want. So times 1 divided by 3. Back again. 92 over 51. Oh, did I times or divide? Something to yeah, 92 over 51. Did I do something wrong way? So Oh, the number's so weird. 34. If I multiply by 34, 1/17. Yep, nothing wrong with it. So far, so good. All right. Sorry, that's a little place for the space for the second one. All right, the second one, you can use elimination if you want. But if you want to do that, you have to move x and y to the left. My suggestion is that if one of the equation is already solved for, like y equal x equals something, the best thing to do is substitution. Right? So x plus, so this one, second equation right here. X plus 2 times y is going to be, instead of y, it's going to be negative x plus 3 plus 1. Oh, no, equal 1. Sorry, equal 1. And now you solve for x, right? So x minus 2x plus 6 equal 1. X minus x is, I'm sorry, x minus 2x is minus x plus 6 equal 1. Subtract 6. So minus 5, x equal 5. And what you want to do is you want to plug it back in right here. So y equal negative 5 plus 3, which is negative 2. So final answer is 5 comma negative 2. Right, and I kind of write order pair for this one too. So 1/17 and 92/51. The answer is such ugly. I wonder if I do something wrong here. Let me know if you have a different answer. If you want to email me. But I mean, in reality, your answer is not integer. It's not like this rarely be integer, because in school people just kind of give you problems with integers, would have answered with integers, so it just feel nicer. But in reality, like practically, if it's in the real world, most of your answer will be irrational or fraction. The sum of two number is negative 26. So number 10 and number 11 is 4.2 and 4.4. The sum of two number is negative 26. One number is 12 less than the other. Find the numbers. Now, you already know how to solve system of two equation. So now, this one, I'm going to show you how to solve it with using two variables, right? So there are two numbers that I'm looking for. Two numbers I'm looking for. So what I'm going to call is, say, let me use red. Let x and y be the two numbers, right? So the first sentence say that sum of the two number is negative 26. Maybe I'll highlight it in blue. So that means x plus y equal negative 26, right? The second one say one of the number is 12 less than the other. So let's just say, I'm gonna say x is bigger than y. Okay, you can do y bigger than x, doesn't matter. So let's just say x is bigger than y. So that means y is equal to x minus 12, right? Because y is smaller, that means 12 is 12 units smaller, so x minus 12. And now you solve. Substitution. Right, so it's gonna be x plus what? Instead of y, it's gonna be x minus 12. That's a y, right? Equal negative 26. Solve, oops, sorry. X plus x is 2x minus 12 equal negative 26. Add 12 both sides, x equal 14. Divide both sides by 2, x equal 7. Now you're going to solve for y. You box that. Y equal, oh, make it smaller. Gonna be 7, let me use blue. 7 minus 12. So y equal negative uh, 5. It is true. Y is 12 units smaller than x. Because if you yeah. All right, number 11. This one a bit not challenging, but it requires a little bit of that common sense, right? So let first thing first, I'm going to draw a little summary. I recommend you learn how to do this. It's very helpful for the exam. I'll remind you again on the lecture. Mhm. Okay. All right. All right. Okay. So, do you agree with me? Is assume that the velocity is constant, it doesn't change, right? So distance is rate times, yes, right? So here we have two situations. The John family took a 12-mile canoe ride down the Indian River in 2 hours. After lunch, they returned. The return trip back up the river took 3 hours. Took longer. Find the rate of the canoe in still water and the rate of the current. So there are two variables that we're looking for here. The velocity or the speed of the canoe, and then the speed of the current of the river. So what I'm going to do, let me move this down a little bit. I'm gonna say, let x be the speed of the of the canoe of the canoe, and y be the speed of the current. You know what? Let me do this. I'm gonna let B and C. B is the speed of the boat. Let's take a new boat. And C is the speed of the current. So it's easy to remember. Now, the distance they travel is the same. Do you agree? But the thing that they travel upriver and downriver. So upriver. So I have two situations here. I have upriver and travel downriver. And we know that distance is they both what? They both 12 miles, right? The only thing changing is the time. So distance is equal rate time. Maybe I'll put the little equal sign here. Equal rate times. So the times for the up river go back up is 3 hours. Yeah. Yeah, go back up is 3 hours, and then you go down 2 hours. So that means when they go down, they have the aid of the speed of the current, right? This kind of help them move along faster. So that means the rate when you go downriver is going to be equal to the rate of the canoe or the rate of the boat, which is B. Maybe I'll rise. Let's use red. Plus the rate of the current. Yeah, and then when you go upriver, you have to go against the current. So the rate of the boat, the speed of the boat minus the speed of the current, you have to overcome the speed of the current in order to move forward. Let me write all the things here in red. 3, 2, 12, 12. And we know this is an equal rate times time, so we have two equations here. It's gonna be B minus C times 3 equal 12, or B plus C, same thing, times 2 equal 12. And then you solve these two systems of equation. So let's see, I have 3B minus 3C equal 12. I have 2B plus 2C equal 12. I was using elimination and I choose to eliminate C. Why do I choose to eliminate C? Because they already opposite. All I have to do is I'm going to multiply the first equation by 2, and then I'm going to multiply the second equation by 3. So that I have 6B minus 6C equal 24. Sorry. And then 6B plus 6C equal 24 again. Then you add. That's cancel. So I have 12B equal 48. Divide both sides by 12. The speed of the boat was the canoe. B equal 4. It's a mile per hour. Yeah, mile per hour. And now you have to solve for the speed of the current. Pick an equation and plug it in, right? So maybe I'll pick this one. So B is 4 plus C times 2 equal 12. 8 plus 2C equal 12. 2C equal 4. C equal 2 miles per hour. So the current is 2 miles per hour. Makes sense. The speed of the canoe should be bigger than the speed of the boat, otherwise you're going backwards. Right? You're gonna overcome